I'm going to say this clearly, without suspense, without theatrics, and without the usual cosmic build-up people expect from me. 3 ISRO is not an alien spacecraft. It never was. And the scientific evidence confirming that fact is not speculative, not philosophical, not a matter of opinion. It is overwhelming, empirical, and beautifully consistent with everything we know about ordinary comets in our solar neighborhood. Over the past several weeks, I've watched speculation explode online. Diagrams of engine vents, talk about hidden propulsion, electromagnetic signatures, and even theories that the object was intentionally slowing down. But real science doesn't bend to viral imagination. Real science demands we look at the data, and when you look at the data, the conclusion is unambiguous. 3 ISRO behaves exactly, precisely, and predictably like a comet. The first decisive blow to the alien hypothesis came from India, from the brilliant team at the Physical Research Laboratory, part of ISRO. They used a 1-meter class telescope perched on Mount Abu, 1,680 meters above sea level, a perfect location for clean seeing, to observe 3 ISRO across several nights in mid-November. When I reviewed their findings, I had the same response any astrophysicist would have. Of course it's a comet. The images showed a nearly spherical coma, a diffuse cloud of dust and sublimated ice enveloping the nucleus. You don't get a coma from metal alloys or composite spacecraft hulls. You get a coma when frozen volatiles, water, ice, carbon dioxide, ammonia, are heated by sunlight and vaporize, dragging dust with them into space. Sublimation is the calling card of comets. It's their signature, their fingerprint. If you heat a spacecraft, it does not shed a natural gas dust envelope that expands outward in a near spherical geometry. If you heat a comet, it absolutely does. The Indian team documented this with remarkable clarity. Their time-resolved imaging showed the coma expanding outward in a manner completely consistent with solar-driven sublimation. No sharp edges, no engineered symmetry, no structural artifacts. But the most compelling evidence wasn't the images, it was the spectroscopy. They spread the object's light into its component wavelengths and discovered distinct emission bands, CN, C2, C3. These molecules are the bread and butter of comet chemistry. CN-, the cyanogen radical dash, is practically a neon sign that says, I am a comet. C2 and C3 diatomic and triatomic carbon appear during the photodissociation of more complex organics released from cometary nuclei. These signatures are not subtle. They are not ambiguous. They do not appear in spacecraft exhaust plumes. They appear in comets, period. And then there was the production rate, about 10 to the 25th molecules per second. When a comet approaches the sun, its ice begins to boil off at rates we can measure by looking at the density and intensity of those emission bands. 10 to the 25th is right in the sweet spot for a modest, typical comet. Not a hyperactive one, not a dying one, not a mysterious object from another galaxy. Just a normal, respectable comet doing what comets do. These data alone would have been enough to scientifically bury the alien craft idea. But science rarely stops at enough. It seeks completeness. It seeks replication. And that's where NASA's multi-platform approach entered the picture. Hubble, James Webb, Mars orbiting satellites, each observed the object independently, using different instruments and different wavelengths, and they all saw the same thing: a coma, a dust tail, and a gas-driven morphology consistent with sublimation, not technology. Hubble detected the faint halo. Webb saw the dusty outflow, capturing the thermal signature of heated particles drifting away from the nucleus. Even imagery from Martian orbiters showed the extending tail stretching along the object's trajectory. These are not behaviors you would expect from a constructed vehicle. Alien technology, if it existed and was capable of interstellar travel, would not conveniently mimic the behavior of a weakly bound aggregate of ice and dust undergoing solar heating. Nicola Fox at NASA summarized it in the most straightforward way I've heard. It behaves exactly like a comet. She emphasized there were no technical signatures, no structured emission lines, no heat dissipation patterns that resembled engines, no anomalous radiation spikes, no evidence of artificial maneuvering. Amit Kshatriya put it even more bluntly. Every piece of evidence points to it being a comet. I've spent my career talking about the future of humanity, the possibility of intelligent life, the tantalizing search for signals in the cosmic dark. I believe firmly that we are not alone. But believing we are not alone is not the same as forcing extraterrestrial explanations onto every passing object. Science is not the art of wishful thinking. It is the discipline of letting reality speak for itself. And here, reality is speaking loudly. A dusty coma, carbon-based emission bands, a steady molecular production rate, and a classic cometary tale are not exotic. They are wonderfully ordinary. They show us that the laws of physics remain universal, that even interstellar visitors obey the same thermodynamic principles we see in our own backyard. I know some people wanted 3I/ATLAS to be something more, something groundbreaking, universe-shifting, paradigm-shattering. But sometimes the cosmos reminds us that truth is not always found in the spectacular. Sometimes it is found in the familiar. And when you understand the physics, the chemistry, the data, the simplest explanation is not only the most reasonable, it is the correct one. When the Indian team released their data, I could almost predict what would happen next. Instead of the findings settling the debate, a new wave of conspiracy theories erupted. Some claimed the coma was artificial camouflage. Others insisted the emission bands were misinterpreted engine chemistry. And a few even argued that the molecular production rates were too perfect, as if an alien civilization had intentionally engineered them to look like a comet. But that's the strange irony of modern science communication. The more precise the evidence becomes, the more imaginative the speculation grows. And yet, as physicists, our responsibility is to peel away the noise and return to fundamentals. So I examined the Indian results from a purely physical standpoint: coma shape, dust distribution, gas expansion velocity, and everything aligned with textbook comet behavior. A real spacecraft, regardless of how advanced it is, would exhibit anisotropic thermal patterns, localized hotspots, structured radiators, directed vents. That's because engineering always reveals itself in symmetry and deliberate design. But 3I/ATLAS showed none of that. Its coma was asymmetrical in the natural chaotic way we expect when subsurface pockets of volatile ice sublimate irregularly. The dust distribution had a gradient consistent with solar radiation pressure. Nothing about the object's glow indicated purposeful manufacturing. Natural processes are messy, machines are not. And this object was messy in exactly the right ways. Around the same time, NASA began releasing its own multi-platform data. This was an important moment because independent validation is the beating heart of science. Hubble's high-resolution imaging revealed a faint but unmistakable tail extending from the coma. The tail's curvature matched models of dust being pushed by the solar wind, a delicate, continuous arc that no propulsion system would ever produce. Propulsion creates thrust vectors, concentrated momentum, sharp boundaries. Solar wind does not. A comet's tail flows, softens, bends. It dances with the sunlight. And 3I/ATLAS was dancing exactly as physics predicts. James Webb added infrared coverage. This was crucial because infrared doesn't lie. If the object were metallic, reflective, or hiding an internal energy source, Webb's sensors would have exposed the heat signatures instantly. Instead, the readings showed something beautifully mundane: warm dust grains cooling as they drifted away. The thermal gradient followed the expected decay curve of particulate matter, leaving an icy nucleus. No anomalies, no hotspots, no engineered thermal emissions. When you look at Webb's plots, they read like perfectly ordinary comet thermodynamics. Then came the surprising contribution from Mars-orbiting satellites. People forget that orbiters around Mars are positioned optimally for parallax-based tracking of interstellar objects. Their data revealed the tail's full extent and even captured subtle fluctuations in brightness as gas jets on the nucleus shifted direction. These jets operate like tiny natural thrusters, nudging the comet ever so slightly, creating micro variations in the light curve. We see this throughout the catalog of known comets, from small dusty ones to the giants with massive outgassing. But what we never see, what no one has ever documented, is precise, repeated, engineered thrust. And 3 I/ATLAS provided nothing of the sort. Nicola Fox's statement struck me for its elegant simplicity. There are no technical signatures. She didn't hedge. She didn't leave the door open to exotic interpretations. She just stated what the instruments recorded. Amit Kshatriya echoed her with equal clarity. Every piece of evidence points to a comet. These were not philosophical musings. They were concise summaries of thousands of data points collected across multiple wavelengths, instruments, and vantage points. If someone asked me what the strongest argument against the alien hypothesis is, I would say it's the convergence of results. Different countries, different teams, different tools, yet the same conclusion. Science becomes powerful when nature repeats itself across independent measurements. And here, nature was shouting. The coma, the dust tail, the gas jets, the emission bands, the molecular production rate. Every physical clue pointed in the same direction. And yet, I empathize with the public's excitement. Humanity is hungry for contact. We look to the sky with a hope that borders on longing. I've spent decades speaking about Type 1 civilizations, star-hopping technology, and the inevitability of cosmic neighbors. But belief must not override observation. If we declare every passing rock an alien artifact, we don't advance science. We undermine it. The universe deserves more respect than that. It deserves our patience, our rigor, and our honesty. 3 I/ATLAS is not a disappointment. It is a reminder that interstellar visitors are real, natural, and governed by the same physics that shape our own solar system. And if we can understand these visitors for what they truly are, we build the foundation to recognize the extraordinary when it truly arrives. What struck me most as the data accumulated was not the comet itself, but how precisely its behavior aligned with the predictions of classical comet physics. For decades, we've modeled how volatile ices respond to solar radiation, how dust tails form, how molecular emission evolves with distance from the sun. When I looked at the curves for 3 I/ATLAS, they matched existing models almost perfectly, not because the object was ordinary, but because nature is consistent across the cosmos. A comet wandering in from another star system isn't exempt from the laws of thermodynamics. Ice sublimates, dust disperses, molecules fluoresce under UV radiation. And that is exactly what the Indian and NASA teams observed. Some skeptics argued that interstellar comets should behave differently, that perhaps the chemistry of another star system would produce unfamiliar signatures. But that assumption misunderstands the universality of carbon-based chemistry. CN, C2, and C3 form readily in many environments, governed by simple energetic pathways. These molecules are not unique to our solar system. They are cosmic commoners, appearing in nebulae, protostellar disks, and even the atmospheres of distant exoplanets. So when PRL detected those emission bands, it wasn't surprising. It was expected. The moment I saw the spectral lines, I knew we were looking at a body shaped by the same chemical heritage as countless comets before it. Then there's the matter of production rate. 10 to the 25th molecules per second is not just typical, it's textbook. If engineers were attempting to mimic comet outgassing, they would need to reproduce this rate with staggering precision, maintain it consistently as the object approached the sun, and cause the gas expansion to produce a coma with natural asymmetry. Such an endeavor would require impossible fine-tuning. Nature, on the other hand, produces that behavior effortlessly. Physics does the work. Solar light heats the surface. Ice sublimates. Dust follows. The Coma forms. And that is what 3I/ATLAS displayed, night after night, observation after observation. The NASA imagery reinforced this truth. The diffuse halo around the nucleus had the exact brightness gradient predicted by sublimation models. There were no structural shadows or angular interruptions, nothing that hinted at machinery, panels, or engineered contours. When I reviewed the Hubble images, I focused on the light distribution within the Coma. It was chaotic, soft, noisy. That irregularity is the hallmark of natural dust. If an artificial object were shedding material, the distribution would be directional, patterned, repeating. But a comet's dust cloud is sculpted by solar wind, radiation pressure, and the random geometry of subsurface ice pockets. 3I/ATLAS behaved like a creature of randomness, not design. Another essential clue was the tail. The tail lengthened as the object approached the sun, bending gently along its trajectory. This bending happens because dust particles are tiny sails pushed by sunlight. Their orbits shift slightly depending on size, mass, and proximity. The result is a graceful curve. I saw that same curve in the images from Mars orbiters. The tail wasn't rigid, wasn't segmented, wasn't mechanical. It swayed, fluctuated, and wavered the way comet tails always do. If this were an engineered exhaust plume, it would exhibit symmetry. It would show periodic jets or thermal pulses. Instead, it showed the gentle physics of dust illuminated by a star. As a physicist, I also studied the object's motion. Alien technology, if it existed and were capable of interstellar travel, would likely use propulsion systems far beyond anything we can imagine. That would leave detectable footprints, alterations in course, controlled deceleration, non-gravitational maneuvering. But 3I/ATLAS followed a clean gravitational trajectory, consistent with its speed, mass, and interstellar origin. The only deviations observed were microaccelerations caused by natural gas jets, the same phenomenon documented in countless comets. These jets even create rotational wobble, which was faintly detected in the photometric fluctuations. It was subtle, delicate, and undeniably natural. The key point here is that the object was predictable. Its brightness curve evolved consistently. Its tail lengthened at the expected rate. Its coma expanded according to models first established decades ago. Nothing about it hinted at control or intelligence. Everything about it reflected physics. And this is what I wish people understood. Alien technology would not hide perfectly within the statistical noise of comet behavior. It would stand out. Extraordinary engineering leaves, extraordinary clues. But 3I/ATLAS left only ordinary ones. Ordinary but beautiful in their own right. I've often said the universe is not only stranger than we think, it's stranger than we can imagine. But sometimes it's also familiar. And in that familiarity lies truth. When you strip away speculation, when you let the data speak with its quiet authority, you find that 3I/ATLAS is telling us a simple, elegant story. It is a visitor from another star, shaped by the same cosmic forces that sculpt our own comets. It is not a messenger from an alien civilization. It is a traveler carrying the chemistry of a distant sun, whispering the language of physics as old as time. As more observatories turned their attention toward 3I/ATLAS, the object transformed from a mysterious silhouette into a fully characterized visitor, a predictable participant in the cosmic ballet. But the more the science clarified its nature, the more the public's fascination shifted toward the philosophical. If it's just a comet, what does that say about our expectations? Why do we leap to the extraordinary when the ordinary is already profound? I thought about this as I sifted through the imagery, particularly the deep field shots from Webb. These images showed not innovation, not technology, but the slow and delicate evaporation of ice grains, cosmic snowflakes sublimating under a sun they had never seen before. There was something poetic about that. This object had wandered for perhaps millions of years through interstellar darkness, without warmth, without light, without a star to call home. And then, for a brief moment, it passed through our neighborhood, and the sun woke it up. Its ices stirred, its molecules began to dance, its dust unfurled into space. It wasn't alien technology, it was alien nature, and that to me is just as compelling. The continued analysis from NASA reaffirmed everything India had reported. One of the most important aspects of their findings involved the absence of technical signatures, a phrase that sounds simple but carries tremendous weight. When scientists look for signs of technology, they aren't looking for blinking lights or structured hulls. They look for deviations from natural physics. Technology introduces purposeful asymmetry. It generates waste heat in concentrated patterns. It radiates non-random energy. It alters trajectories with intent. None of those markers were present. Instead, every wavelength told the same story. Thermal emissions aligned with dust cooling curves, visible light reflected off irregular particulate clouds, ultraviolet radiation triggered molecular fluorescence. Even the Coma's density profile followed predictions from sublimation models created long before anyone had ever heard of 3I/ATLAS. This convergence is what fascinates me, how different instruments, detecting different energies from different vantage points, all pointed toward the same conclusion. I looked particularly at the rotational light curve data. The tiny oscillations in brightness indicated a nucleus that was spinning irregularly, with jets firing from multiple points on its surface. These jets are chaotic by nature, formed by pockets of ice breaking open as internal pressure rises. They create small, unpredictable nudges, natural randomness encoded directly into the object's motion. A spacecraft, even one built by an advanced civilization, would not reveal such uncontrolled volatile bursts. It would regulate its movement, it would exhibit precision, but nature does not regulate, it expresses, and 3I/ATLAS expressed itself exactly as a comet should. The Mars-based observations offered another layer of confirmation. The planet's orbit placed its satellites in a unique geometric position relative to the comet's path, allowing them to detect faint asymmetries in the tail's curvature. These asymmetries matched the predicted impact of solar wind variations. No propulsion system, no exhaust plume, no engineered output behaves like that. Solar wind is erratic, shifting as it interacts with the sun's magnetic field. It produces bends, ripples, and distortions in comet tails, distortions that were visible in 3I/ATLAS with remarkable clarity. Still, the calls for alien explanations persisted. Some argued that perhaps the object was intentionally disguising itself, or that its creators had engineered it to mimic cometary behavior, but that argument collapses under its own weight. Why would a civilization capable of crossing interstellar distances rely on subterfuge so perfect, so comprehensive, that every physical property down to molecular emission matched a natural object? And if such a civilization existed, why would they send a craft that released chaotic jets, dust clouds, and uncontrolled outgassing? The idea doesn't merely stretch plausibility, it tears it apart. The truth is that science is not just about identifying extraordinary possibilities, it's about understanding the ordinary with extraordinary depth. And in the case of 3I/ATLAS, the ordinary was astonishing enough. An object born under a different sun, carrying ice from a distant system, sublimating under the warmth of ours. That alone is a cosmic treasure. It tells us that our solar system is not isolated. It reminds us that debris from other worlds drifts through interstellar space, crossing boundaries we once thought insurmountable. The universe is not a collection of separate islands. It's an ocean, and objects like 3I/ATLAS are the waves that occasionally wash onto our shores. By the time all the data had been compiled, the conclusion was airtight. Not speculative, not interpretive, just scientific. Every measurement from India, from NASA, from Mars orbiters, from ground-based telescopes across the globe converged on a single identity, a comet. Not a craft, not a message, not a vessel. A comet, behaving exactly as comets do, governed by physics that cares nothing for our hopes or fears. And for me, that's enough, not because it diminishes the possibility of extraterrestrial life, but because it reinforces the credibility of the science that will ultimately help us find it. As the final datasets arrived and the last observations were logged, the scientific story of 3I/ATLAS drew to a close, not with a revelation about alien contact, but with something quieter, more disciplined, and ultimately more illuminating. The object had revealed itself fully, its coma, its tail, its molecular breath, its chaotic jets, all of it painted a portrait of an interstellar comet obeying the same universal laws that govern the icy wanderers of our own solar system. In a way, it was a cosmic mirror, reflecting back to us the consistency of nature across unimaginable distances. I kept returning to the question so many people asked, if it wasn't an alien craft, does that make it less meaningful? And my answer every time was no. In fact, it's more meaningful precisely because it is natural. If every anomaly became a placeholder for extraterrestrial engineering, we'd lose the very framework that lets us distinguish the extraordinary from the ordinary. Science is a filter. It narrows chaos into clarity. It tells us when something is remarkable and when it is simply playing by the rules of physics. 3I/ATLAS played by those rules perfectly. Its chemistry told the story of interstellar ice. Its dust tail illustrated the subtle push of sunlight. Its spectral lines whispered the same molecular history we've seen in comets for generations. Its trajectory, unchanged by intention or control, revealed a path shaped only by gravity and gentle outgassing. And its behavior matched models built long before this object ever entered our skies. That alignment across research teams, across continents, across different instruments and wavelengths, is what gave the conclusion strength. It wasn't one scientist saying it's a comet. It was dozens of independent observations shouting the same thing in unison. What fascinates me is what this means for the future. By confirming 3I/ATLAS as a comet, we preserve the integrity of the tools that will one day identify something truly artificial. If everything becomes alien by assumption, then nothing is alien by evidence. To find extraordinary life, we must first master the ordinary universe. We must understand every signature of natural objects so thoroughly that when an unnatural one appears, it shines unmistakably against the background. And so 3I/ATLAS leaves us with a scientific gift. It proves we can detect, analyze, and characterize interstellar visitors with remarkable precision. It proves our instruments on Earth in orbit around Mars are working together as a unified observatory for the planet. It proves international collaboration is not optional but essential. India's measurements, NASA's confirmations, the global scientific community's scrutiny, they form a chain of trust that strengthens our understanding of the cosmos. But more than anything, this comet reminds us that the universe is vast and full of wanderers. Some will drift into our neighborhood carrying only ice and dust. Others, someday, may carry evidence of something more. But we cannot force that day to arrive through speculation. We must earn it through rigor. When I look back on the story of 3I/ATLAS, I don't see disappointment. I see progress. I see a species sharpening its tools, testing its theories, refining its expectations. I see the beauty of a natural interstellar traveler briefly illuminated by our sun, offering us a glimpse of chemistry shaped under a different star. That is a wonder in itself. And when the next object arrives, and it will, I hope we meet it with the same scientific discipline, the same curiosity, and the same respect for the evidence. Because one day, maybe sooner than we expect, something will appear that does not fit the models, that does not obey the curves, that does not mirror the behavior of comets or asteroids. And when that happens, the world will know. No speculation, no ambiguity, the data will speak. Until then, 3I/ATLAS stands as a testament to a simple truth. The universe is extraordinary even when it is not exotic. And if we listen carefully, even a comet can teach us how to search patiently, rigorously, and honestly for company among the stars.